The transpose of a matrix is an operator which changes rows to columns and columns to rows. Let A be an m by n matrix. The transpose of A, noted A T, is equals AGI, and the transpose is an element of R n by m, so the transpose is an n by m matrix. Notice that the dimensions too are flipped, so the number of rows of A becomes the number of columns of A transpose, and the number of columns of A becomes the number of rows of A transpose. Also, AIG becomes AGI, so if A12 equals 8, it means A21 is 8 for A transpose. Let's get into more details. With A given to us, we can always obtain A transpose. Notice that the row or the first row of A becomes the first column of A transpose. Then the second row of A becomes the second column of A transpose. The n-1th row of A becomes the m-1th column of A transpose, and the mth row of A becomes the mth column of A transpose. So it's some sort of row and column flipping, wherein the rows become the columns in the transpose. The matrix transpose has some properties. The transpose of a matrix is equals to that matrix. The transpose of the sum of two matrices A and B is equals the transpose of A plus the transpose of B. The transpose of the product of two matrices AB is equals to B transpose times A transpose. The transpose of the product of three matrices A, B, and C equals the transpose of C times the transpose of B times the transpose of A. This actually is not a very new property. It is the same as this property which was given earlier. Now, to generalize this property, the transpose of A1 times A2 times A3 to AN is equals the transpose of AN times the transpose of AN minus 1 to the transpose of A2 times the transpose of A1. These properties are very useful and shall be used in subsequent chapters. Now you can test your knowledge by finding the transpose of the following matrices. So you will find AT, find BT, find AB, find AB transpose, find BT transpose times AT. Then you can confirm that AB transpose equals BT times AT. So we take another break. Feel free to pause the video and find the transpose of these two matrices. Recall that to find the transpose of a matrix A, the rows become the columns and the columns become the rows. Let's look at the solution. With A being a 2 by 3 matrix, normally A transpose should be a 3 by 2 matrix, which is the case. Now, notice that 572, which represents the first row of A, becomes the first column of A transpose, and 314, which represents the second row of A, becomes the second column of A transpose. For B, the first row of B becomes the first column of B transpose. The second row of B becomes the second row, or rather the second column of B transpose. The third row of B becomes the third column of B transpose. Another way of looking at it is we have the first column of A becomes the first row of AT. The second column of A becomes the second row of AT. The third column of A becomes the third row of AT. Then the first column of B becomes the first row of BT. The second column of B becomes the second row of BT. The third column of B becomes the third row of B. Let's get AB. Multiplying A and B involves getting all these new elements. To get the element on the first row, first column, we multiply the first row of A by the first column of B. So we've got 5 times 1 giving us 5, plus 7 times 0, which is 0, plus 2 times 0, which is 0. So we end up with 5 plus 0 plus 0 giving us 5. Next, to get the element on the first row, second column, we have 5 times 5, which is 25, plus 7 times 0, which is 0, so we have 25 plus 0, plus 2 times 2, which is 4, so we have 25 plus 4, giving us 29. Next, we have the first row, third column, so we have 5 times 1, which is 5, 7 times negative 3, negative 21, 5 minus negative 21 is negative 16, plus 2 times 2, which is 4, negative 16 plus 4 gives us negative 12. Then the element on the second row, first column, which is this, we have 3, second row, 3 times 1, which is 3, plus 1 times 0, plus 4 times 0, so we end up with 3. Then we're looking for the elements on the second row, second column. So we have second row, second column, 3 times 5, which is 15, plus 1 times 0, 0, so we are left with 15, plus 4 times 2, 8. 15 plus 8 is 23. Then lastly, the element on the second row, third column. Here we have second row and third column. 3 times 1, 3. 1 times negative 3, negative 3. 3 plus negative 3 is 0. 4 times 2, 8. 0 plus 8 gives 8. So we have 8. Now, AB transpose, we take our first row, or rather, the first column becomes the first row, second column becomes the second row, third column becomes third row. Now we multiply B transpose by A transpose. So BT times AT gives us 5, 3, 29, 23, negative 12, 8. With this, you can confirm that AB transpose equals B transpose times A transpose. So the matrix transpose basically allows us to flip a matrix.
On our platform, select the course you're interested in taking, apply for a scholarship, and then attach a short video or screenshot showing that ABC transpose is equal C transpose B transpose A transpose, using the fact that AB transpose equals B transpose A transpose. Special thanks to our donors who are making this giveaways possible.
Our next operation, which involves a single matrix, is a matrix inverse. Finding the matrix inverse will entail more calculations than what we've done so far for the matrix transpose.